exponential and logarithmic equations. So let's talk about how to solve these rascals, these logarithmic and exponential equations. Pretty cool setup. Everything is based on the definition and also the properties that we've talked about before. That is, the property going from the log of the product is equal to the sum of the logs, and that the log of the quotient is equal to the difference of the logs. And then the power rule, the log of x raised to the nth power is equal to n times the log um, of x. So we use those, and pretty neat. We can solve these problems. So let's look at some problems, and we're going from, say, for example, the exponential to log form. Just be mindful of the setup, and basically, either we manipulate the definition, apply the definition, or eventually, if it's in exponential, we can take the natural log of both sides and get it quickly. How about that? Let's see. Here, just some steps that we'll use. That's good. Let's talk about them as we work the problems. So say, for example, let's start here with this one. So we're going to solve this. We're going to solve for x. So in doing that, I want to be able to break down that 243. So I'm going to take 243 divided by 3, and that gives me 81. So this is 3 times 81. Now I know what 81 is. Well, so this is 9 times 9. So this is 3 times 3 times 3 times 3 times 3. Let's count them up. And why do we want base 3? Because I have base 3 right there. So this is 3 to the 5th. So let's put it all together. This is 3x is equal to 3 to the 5th. If the bases are the same, then you set the exponents equal. So this implies that x is equal to 5. Okay? That's all. Next, very similar setup here, but again, I need to take that 343. Since they give me a base of 7 here, I'm going to divide 343 by 7. And when I do that, I get 7 times 49. Well, that's cool because 49 is 7 times 7. This is 7 to the 3rd power. So what I end up with is 7 to the 2x minus 1 is equal to 7 to the 3rd. Again, the bases are the same. That implies that the exponents are equal. 2x minus 1 is equal to 3. Now this is in algebra world. So now I can just solve that. So I just solve for x. You add 1 on both sides, divide by 2, and you see that x is equal to 2, right? So we have 2x is equal to 4, x is equal to 2. Now, later on, we'll talk about making sure that the answer satisfies the domain. And this one does, so nothing to worry about there. But once we get to that, I'll definitely let you know what's happening. Now, look at this 64. Look at that base. Look at 32. Well, there's something common there, but we have to kind of dig for it. So it looks like maybe the common base is going to be 2. So let's take the 64. So we know that this is 8 times 8. Well, 8 is 2 to the 3rd times 2 to the 3rd. So this is 2 to the 6th. The 32 is 2 to the 5th, right? So we said this implies that this is 2 to the 6th raised to the x power is equal to 2 to the 5th power. So the bases are the same. You have over here, you have a power raised to a power, you multiply the powers. This is implied. So this is 2 to the 6x is equal to 2 to the 5th. Bases are the same. We set the exponents equal. 6x is equal to 5. X is equal to 5 over 6. Okay. Still, again, more of the same. You want to make sure that before I can set the exponents equal, you got to have the same base. But notice that this 1 over 9 is 9 to the negative first power. But that 9 is 3 to the second. That's raised to the negative first power. So this is 3 to the negative 2. And you could have dealt with that when the 9 was downstairs. Doesn't matter. This is 1 over 3 to the second. But that becomes 3 to the negative 2. So the bases are the same. The bases are loaded. Bases are the same, so we set the exponents equal. So that's 5 minus x is equal to negative 2. I'm going to add x on both sides and then add 2 on both sides, so I get 7 is equal to x. And it's just always good to check, just to make sure that we're good. So if that's the case, if x is equal to 7, this is 3 to the 5 minus 7. This is equal to that 1 over 9. Well, this is 3 to the negative 2 is equal to 1 over 9. That's indeed correct. This is 1 over 3 to the second equal to 1 over 9. Well, that's 1 over 9 is equal to 1 over 9. Can't get more equivalent than that. All right, again, the key is get the bases to be the same. Looks like base 4 is going to be the key. So this is 4 raised to the x minus 3 over 10 is equal to 4 raised to the 1/2 power. So I'm setting x minus 3 over 10 equal to 1/2. So this implies then that x minus 3 over 10 is equal to 1/2. So just an algebra problem now. So multiply both sides by the 10. So I have x minus 3. Sorry, I'm getting the answer in my crazy warped head. So 1/2 times 10 is 5. Right? And then I get x is equal to 8. Again, let's make sure that makes sense. So this is 4 to the 8 minus 3 over 10. This is 4 to the 5 over 10. That's 4 to the 1/2. Well, that's the square root of 4. I did say didn't, but that was a check. Check. All right. Again, look at the bases. We got to make sure the bases are the same. Bases are loaded. Down by 6 in the 9th. Well, 625 is the same thing as 25 times 25. Right? So this is 25 to the x plus 8 is equal to 25 to the second, and then that's being raised to the x minus 4. So this is 25 to the x plus 8 is equal to 25 raised to, this is a power raised to a power, so that becomes, you multiply the power, so that's 2x minus 8. So now the bases are the same, so set the exponents equal. So we have x plus 8 is equal to 2x minus 8. Now this is an algebra world, right? So we went from that logarithmic world to algebra world. Now let's solve for x. So I'm going to subtract x on both sides and add 8 on both sides. So I get 16 is equal to x. Right? By all means, let's check just to make sure. No guessing. You don't have to ask anybody, is this right? You just check yourself. 25 to the 16 plus 8. Is that the same thing as 625 to the 16 minus 4? Let's see. This is 25 here to the, that's a pretty big number, right? So it's to the 24th power. Question, is that the same thing as 625 to the 12th. Well, notice that 625 is the same thing as 25 to the second, and then that's being raised to the 12th. Excuse me. Power raised to a power, multiply the powers is 25 to the 24th power is equal to 25 to the 24th power. So we're good. So x is indeed equal to 16. I keep forgetting. Solve the exponential equation. Express the solution in terms of natural logarithms or common logarithms. Then use a calculator to obtain a decimal approximation. All right. So no problem. So here's what we're going to do. If the base is 10, see that base is 10 there, then we're going to take the common log of both sides. I'm trying to think, did we use the change of base formula? Was that the previous section that, um, I don't know if we had a problem that used that. I'm sorry. Um, it comes up here, and so we use the change of base formula. Oh, forgive me. I think that was in the previous section, but I didn't have a homework problem that dealt with that. I don't believe. I don't recall. I haven't had my lunch yet either, so that could have something to do with it. So anyway, this is common. A common base there is 10. Now, a couple of ways you can do that. We can just convert this by the definition. This is base 10 to the x power is equal to 3.42. This is if and only if log base 10 of 3.42 is equal to x. And here you get the answer. So you're going to plug in here, type in log base 10 of 3.42. Now they want you to solve it to get the decimal. So here we use the change of base formula. Didn't use it in the previous section. Change of base formula. So I have log base b of x. I'm going to change this to log base a, right? Going there of x divided by log base a of b. And here, make sure that you let a be a base that is easily obtainable. Okay. Like a equal to, this is already in base 10, so you can find that on your calculator. I'm sorry. Like a equal to 10 or a equal to e. I don't need this. This is already base 10. Duh, your calculator has that already. So, all right. So on your calculator, you find that log base 10. I'm gonna do it using this change of base formula too, just to show you that. But we have base 10 on our calculator. So I'm gonna type in on my calculator this is just old Texas Instrument 3.42, and then I'm gonna hit just log, and it gives me 0.534, and just go out here, it says the two decimals, so 0.53. Okay, so that was that. I forgot this is base 10, so that's common and good. But looking at this change of base formula, if I use that, I'm going to change it to let's say, for example, the natural log. This is base 10 of 3.42. Then that becomes the natural log of 3.42 over the natural log of 10. Now, if you do that on your calculator, you kind of have to um, make sure you work that division out. But I'm going to hit the 3.42 natural log divided by 10. That's the wrong button. 3.42 natural log divided by 10 natural log equal 0.534. Right? Didn't really need to change the base here because base 10, the common base, is already on the calculator. All right. Oh, this is cool. This is base E. So good thing there. Now, I told you there's a couple of ways of solving these problems. If I go back over here, I can take the log common base log 10 of both sides and get the answer as well too. So, or take the log of both sides. You know, before you um, remove the speck out of your brother's eye, first remove the log out of your eye. You didn't know that logarithms was in the Bible. Take the log of both. I just made that. That just came to me. That's pretty good. Somebody write that down, man. You get some jokes. So, I'm going to take, this is the log of 10x is equal to the log of 3.42. Make that x the multiplier. So this is x times log of 10 is equal to log of 3.42. Now log of 10, since it's common base of 10, that's just 1. So this implies that x is equal to log of 3.42. Well, that's what you already have, you know, right here. Let me show you that with this method. Take here, the base is e. I take the natural log because the natural log and e are inverses of each other. Natural log of x and e to the x are inverse functions. So this implies, watch this. This is the natural log of e to the 1 minus 4x is equal to the natural log of 2419. This implies that power over here becomes the multiplier 1 minus 4x. Put that in parentheses. Put that in parentheses times the natural log of e is equal to the natural log of 2419. Well, the natural log of e is 1. That's a property. So this is 1 minus 4x is equal to the natural log of 2419. We're solving for x. We're solving for x. So we got to use the algebra to get x by itself. So we're going to subtract 1 on both sides. So I get negative 4x is equal to negative 1 plus the natural log of 2419. Safe to put the minus 1 in the front of this natural log so you don't get the 1 confused with the 2419. The 2419 is not a number by itself. It's the natural log of that, which is something different. Now divide both sides by that negative 4, and so we get x is equal to negative 1 plus the natural log of 2419 all over negative 4. So that's what you're going to put in that first box. So in that first box, you're going to type that in. You're going to type in what? Negative 1 plus the natural log of 2419 all over negative 4. Then on your calculator, you calculate that. And I get something like, this is negative 1.6978. And it says round that to 2 decimals. So this is negative 1.7. You're going to round that 7 to that 9. That becomes a 10. That just becomes a 70. So in there, you put in 1.7. Negative 1.7, excuse me. All right. So here, we take the natural log of both sides. Take the natural log of both sides. This is the natural log of 3 to the 5x plus 4 is equal to the natural log of 7 to the x minus 3. All right. Now I use the power to the multiplier rule, right? So this is 5x plus 4 in parentheses because it's an expression times the natural log of 3 is equal to x minus 3 in parentheses times the natural log of 7. Here the goal is to solve for x, get x by itself. So again, it's just algebra. So we're going to clean this up. It's going to distribute. This is 5x times the natural log of 3 plus 4 times the natural log of 3 is equal to x times the natural log of 7 minus 3 times the natural log of 7. Now we get the x terms on the left side, get the terms with no x's on the right side. So this is 5x, the natural log of 3, minus x, natural log of 7, is equal to minus 4, natural log of 3, minus 3 times the natural log of 7. Factor out the x on the left side, so this is x times parentheses, 5 natural log of 3, minus the natural log of 7 is equal to negative 4, natural log of 3, minus 3 times the natural log of 7. So divide both sides by this term that's multiplied to this x, and I get what I want. So here I get x is equal to negative 4 natural log of 3 minus 3 times the natural log of 7 all over 5 times the natural log of 3 minus the natural log of 7. So that's what you're going to put here in this box, right? And then you work that on your calculator. That's a whole lot. You got to be careful how you put that in your calculator. But when you work that out, that guy comes out to be negative 2.88. Negative 2.88. Okay. And you would think almost that it would be negative 2.89. It's going to kick that out because the number comes out to be, this number comes out to be negative 2.8846. Okay. So I would, I would kind of think, and maybe I'm wrong, I would round that 6 up on that 4 to 5, then that 5 rounds up that 8 to a 9. But they only do the rounding based on one digit to the right. So it's just based on the 4. And so that 8 stays the same. So that's how they get negative 2.88. Right? Solve this guy. Be sure to reject any value of x that is not in the domain. That means check to make sure that the answer satisfies the domain. Here, our domain would be x has to be, well, x plus 6 has to be greater than 0. That is, whatever value of x we get, it has to be greater than negative 6. So this is our domain. So based on the definition, this is base 5 raised to the 3 is equal to x plus 6. So this is if and only if 5 to the 3rd is equal to x plus 6. Now, 5 to the 3rd is 5 times 5 times 5. So what is that, 125? So we have 125 is equal to x plus 6. I get x, subtract both sides by 6. From that 125, you get 119. And indeed, 119 is greater than negative 6. So it satisfies that. Okay. All right. Here, let's solve and then check. So notice that the 5 can be divided into that 25. So just divide both sides by 5. So that gives us the natural log of 3x is equal to 25 divided by 5. We just get 5, right? So a couple of ways you can use the definition, get the answer, or you can, if it's natural log, you raise both sides to the e. Raise both sides with the e base, excuse me. So this is e to the natural log of 3x is equal to e to the 5. Why do we do that? I do that because I have this natural log, that ln. Natural log and the e functions are inverses of each other. So that left side is automatically just 3x is equal to e to the 5th power. So x is equal to e to the 5th all over 3. So here it said the exact value is e to the 5th all over 3. You put that in there in my math lab. Now on your calculator, you want to find e to the 5th, calculate that divided by 3. So that guy gives you 49.47. All right. All right, here, solve this logarithmic equation. We got to check to make sure that the values will satisfy our domain. All right, let's solve first. So this is log base 6 of x plus 8, excuse me, times x plus 3 is equal to 1. Remember that plus sign means this becomes the log of the products. Now, if I use the definition says 6 to the 1 is equal to x plus 8 times x plus 3. So here, 6 to the 1 is equal to x plus 8 times x plus 3. So this is 6 is equal to, for that out, this is x squared plus 11x plus 24. Subtract 6 on both sides. 0 is equal to x squared plus 11x plus 18. So we just get x squared plus 11x plus 18 equal to 0. Factor, if we can, x plus, is that 9 and 2? So x equal to -9, x equal to -2. So we have to check, make sure that these numbers work. Check x equal to -9. So go back and look at the expression up here. So this would be the log base 6 of -9 plus 8 plus log base 6 of -9 plus 3. This gives me log base 6 of -1 plus log base 6 of -6. Cannot take the log or the natural log of a negative number. The value here has to be greater than 0. Here we get negative numbers, right? This is not allowed in the domain. You check that. So x equal to -9 doesn't work. Now let's check x equal to -2. Go back to the original equation. So we have log base 6 of -2 plus 8 plus log base 6 of -2 plus 3. So this is log base 6 of 6 plus log base 6 of 1. Well, these numbers are positive. Log base 6 of 6 is equal to 1. I mean, we're finished. This works. So the only answer we have is x equal to -2. But log base 6 of 6 equal to 1. Log base 6 of 1, that means that this is basically 6 raised to the 0 power is equal to 1. So this is just 0. That's why the answer over there, that's why it's equal to 1 right here. So we got two numbers for possible answer, but we checked both of them for with respect to our domain. Only one satisfied the domain. So that's why x equal -2 is the only solution. You got to be able to check that, folks. All right. So let's look at this. If it's, again, you remember logs plus, that means we're going to multiply. Minus means it's going to be a fraction downstairs. So this is log base 7 of x minus 8 parentheses times x minus 2 all over x. And that guy is equal to 1. I use the definition. So this is base 7 raised to the first power. Where's the first power? That's it right there. That's equal to all this stuff right here. Right? Remember that definition. Log base a of x is equal to y if and only if a to the y is equal to x. So this is equal to x minus 8 times x minus 2 all over x. So multiply both sides by the x to clear the fraction. So this is 7x is equal to that x minus 8. You could go ahead and FOIL that if you want to and just save a step. So this is 7x is equal to x squared minus 10x plus 16. Subtract 7x on both sides. Just write it down here. So this is, we got 7x is equal to x squared minus 10x plus 16. Subtract 7x on both sides. So we're going to factor. Looks like x minus 16 and x minus 1 equal to 0. So we get x equal to 16 and x equal to 1. So we check. We're going to plug in 16 for x. I get positive, positive, positive. That's good. Check x equal to 1. 1 minus 8 is negative. So x equal 1 doesn't work. So x equal to 16 is the answer. So look at the original. This is log base 7 of 16 minus 8 plus log base 7 of 16 minus 2 minus log base 7 of 16. They're all positive. It's good. I'm going to get a result. So now we check x equal to 1. Plug that into the original. This is log base 7 of 1 minus 8. That result is negative. You can stop there. Log base 7. Just takes 1 to fail. This is 1 minus 2 minus log base 7 of 1. So this is negative. Log base 7 of negative 7 plus log base 7 of -1 negative, negative. I mean, if you look at it, you don't have to even work all this out. So we reject x equal to 1. So our only solution is x equal to 16. All right, let's look at this one. If you don't see the base, it's the common base of 10. Right? So let's see what we have here. This is log of x plus 8 minus, I'm getting all the logs on the same side, minus that minus log of 8, that's equal to 0. Okay. So now I can use the expansion condensing formula. So this is log of x plus 8 all over 8x is equal to 0. Use the definition. So this is base 10. If it's not given, it's understood to be base 10. So this is base 10 raised to the 0 is equal to x plus 8 all over 8x. Well, 10 to the 0 is just 1 is equal to x plus 8 over 8x. Multiply both sides by 8x, so I get 8x is equal to x plus 8. Subtract x on both sides, so I get 7x is equal to 8. X is equal to 8 over 7. And it said type of integer or simplified fraction, so 8 over 7 is sufficient. Hey, that's it. We're done.